This demo presents an autonomous AI research assistant designed to analyze and synthesize academic literature using a multi-agent architecture. The system goes beyond traditional retrieval-augmented generation by combining fine-tuned large language models with agentic orchestration. A user begins by submitting a high-level research query through the interface. Rather than treating the request as a single prompt, the system decomposes it into structured tasks executed by specialized agents. The workflow is orchestrated using LangGraph, where each node represents an autonomous agent operating within a directed and stateful execution graph. The keyword agent transforms the user query into optimized search terms using strict output constraints to prevent hallucinations. These terms are passed to the search agent, which retrieves relevant academic papers from real-time sources such as ArcSfor and Semantic Scholar. Retrieved documents are evaluated by a ranking agent that scores relevance using citation velocity and semantic similarity. High-confidence papers are forwarded to the summarization stage. Summarization is handled by a locally fine-tuned Llama 3-8B model adapted using LoRA for domain-specific academic reasoning. Parameter-efficient fine-tuning enables high factual alignment while maintaining low memory usage through quantization. Individual summaries are then processed by a comparison agent that synthesizes cross-paper insights, identifies shared themes, and highlights contradictions. The final output is a structured research report optimized for clarity, accuracy, and technical depth. Strict schema enforcement ensures stable, deterministic outputs across all agents. This project demonstrates how fine-tuned language models and agentic workflows can be combined to build production-grade AI research systems. The full source code and documentation are available in the repository linked below.